The Internet of Things, or IoT, is comprised of millions of devices connected via the Internet to corporate databases and applications. While IoT promises rapid gains in business productivity and efficiency, this massively connected system poses a great risk to industry and consumers. Why? Because like a chain, a connected system is only as strong as its weakest link. If proper security measures are not taken, it can impact brand image, customer trust, and business value. Indeed, if these weak links are not secured, malicious attacks are able to infiltrate the IoT infrastructure. We have already seen examples of such hacks where one unsecured device or node becomes the doorway to infecting and potentially crippling the entire system. What is needed is a trustworthy system. But what exactly does that mean? It means each device in that system is trustworthy, as are interactions between these devices. It means that any data stored on the device or sent from one to another is protected. And it means that any commands transmitted through the system are verified and authenticated. This is only possible if security is at the very foundation of the device. In other words, security is built in, not bolted on. Achieving end-to-end trust starts with implementing a root of trust. It is essential in a secure system and is perhaps the single most important factor in establishing device integrity. ARM Trust Zone is an example of a hardware root of trust that chip companies implement as part of their microprocessor designs. ARM Trust Zone-enabled microprocessors provide a secure, on-chip enclave. Device makers utilize the ARM Trust Zone to isolate and protect functions that are critical to securing a device. Also essential to achieving end-to-end trust is protecting data on the device or during transmission. Implementing encryption enables maintaining the confidentiality of data. Authentication of each device is necessary to ensure that communication occurs only between devices with the proper credentials. Typically, this is achieved via exchanging device keys and certificates. Care must be taken to not use the same key to authenticate all devices. Different key pairs should be used between devices in order to contain the impact of a potential breach. In summary, end-to-end trust is achieved when the integrity of each device is ensured, when data is protected at rest and in transit, and when credentials of each device in a system are verifiable. In this demo, we have several devices that comprise our secure IoT system. Here we have a typical door lock. It is operated by a control unit that accepts remote commands to unlock the door. The control unit also has a camera that takes pictures of anyone who is standing at the door. The control unit is powered by a microcontroller. It implements a root of trust that enables it to boot securely. The unit also includes a cryptography chip that stores a private key for authenticating itself to other devices and validating remote commands. Here we have the secure gateway. It acts as a secure intermediary between the user's phone and the door control unit and camera. The gateway runs on a microprocessor with ARM Trust Zone. Trust Zone establishes a secure isolated zone on the microprocessor for executing functions critical to securing the gateway. Sequitur's Core T is a trusted execution environment, essentially a secure operating system that resides in Trust Zone and provides developers with features necessary for utilizing Trust Zone. Trust Zone and Core T together perform the following security functions in this demo. They provide a root of trust for the gateway. They enable authentication on each device in the system. They provide the cryptographic resources needed to decrypt images from the camera, recrypt the images, and send them to the user's mobile phone. They verify commands from the user and forward them to the door lock unit for execution. Finally, we have the mobile phone that runs a trusted application to securely request the capture picture and the unlock door commands. It also will display the captured image to the user. The mobile phone also runs on a microprocessor with ARM TrustZone. The application requesting a picture and sending an unlock command runs in TrustZone and is protected from compromise. The demonstration you are about to see illustrates end-to-end trust in an IoT system. Using a simple camera and door lock mechanism, we will verify the identity of a visitor prior to unlocking the door. Keep in mind that a camera and door lock edge node is just one potential scenario. The edge node can be any number of things. We begin with the premise that an unknown visitor rang the doorbell. Using our trusted application, the user clicks Capture Photo to use the camera edge node to see who is at the door. The application will switch over to the TrustZone outside the control of Android to capture the PIN. Once the PIN has been captured, it will send the signed message to the gateway, which verifies the legitimacy of the signature from the TrustZone on the mobile device. The verification process takes place in the TrustZone and Core T on the gateway A5D2. Following verification, the gateway will create and sign a command within Core T in the TrustZone, which is sent to the edge node. The signed command is delivered to the edge node on the V71 and is verified in the ECC 508 secure element. The V71 is now taking a picture of the visitor, and the picture is displayed on the screen and on the device. The user recognizes the visitor and allows her through the door by clicking Unlock Door in the trusted application, which, again, switches into the TrustZone. For the purposes of this demo, the user verifies the PIN code again to open the door. The gateway verifies the command and the door lock unlocks for 5 seconds, allowing the visitor to enter. This is just one example. End-to-end trust is achievable in any scenario involving multiple IoT devices connected to each other and to the internet. Achieving end-to-end trust requires security be designed in at the foundational level so that it can be propagated throughout the system. Technologies like ARM TrustZone and T's like Sequitur Core T are rapidly becoming the standard for establishing end-to-end trust in IoT devices and systems. To learn more about these technologies, call us at Sequitur Labs. We would be happy to help. In today's interconnected world, system-wide trust is an IoT must.